I'm here at the MDN website, MDN Web Docs. Let's see what the MDN says about the hoisting. It says conceptually, for example, a strict definition of hoisting suggests that the variable in function declarations are physically moved to the top of your code, but this is not in fact what happens. Instead, the variable in function declarations are put into the memory during the compile phase, but it stays exactly where you type them in your code. This is because some developers think that when you have the function declaration and variables, it will be physically moved to the top of your code. But according to the MDN, it says that this is not in fact what happens. What actually happens is that the variable and function declarations are put into the memory during the compile phase. It also talks about the creation and execution phases in the global execution context. So I'd like to talk a little bit about the global execution context, and then we will dive into the hoisting. To visually see the global execution context, I would like to give an example. Let's create a variable called myNumber equal to 10, and let's create a function declaration called times 10, and it will take number, return number times 10. Okay, now let's store the function in a variable called the result times 10. Now we can pass our variable myNumber and the times 10 myNumber. Okay, now let's console.log result. Okay, so here we see the 100. What it will do, it will take a number and it will return number times 10. As we see here, it's a very small and very simple code. So in order to see the global execution context, I have here a website called JavaScript Visualizer. So here I have the same code for myNumber, and then we have the function called times 10. Okay, so to see the global execution context, let me click the step. And the step 1, there are two phases in the global execution context. The first phase is called creation. In the creation phase, what will happen, it will take all our variables and function declarations and put it in the memory and initialize it as undefined. So as we see here, we have a variable called myNumber, and here in the creation phase we have myNumber as undefined, and we have also a function declaration here. There's also window, which is global object, and this which points to the window. We also have another variable called result that is undefined. So this was the phase 1. Now let's click the step and see the next phase. Okay, so in the next phase, which is called the execution phase, in the execution phase, what will happen, it will read all our code line by line. So now it will start from the line 1. As we see here, it is highlighted. Okay, so in the line 1, it will read myNumber, and then it will put the value of myNumber as 10, because the value of myNumber is 10. Now let's see the next step. And the next step, it will read execute the function, and then it will execute the result. The result will call the times 10 function. So now we have the times 10. Once we call a function, the function declaration, there will be another execution context. So there are two global execution contexts, one global, which is for our whole code, and one for the functions. So in the function execution context, we also have creation phase and execution phase. In the creation phase, it put all our variables and other function declarations. So as we see here, it also put the arguments. In the arguments, we have one argument, and the value is 10 at the index of 0, and the length is 1. There's also this which points to the window, and there's a number that is 10. Okay, so now let's see the next step. Then the next step, we have the execution phase also in the function execution context. Now it will execute all our codes inside the function. As we see here, the number times 10 is highlighted. Okay, now it will execute that. Once the calculation is done, it will take that value or the result and put it in the result variable. So now let's see the result. Right now the result is undefined. Once the function is completed the operation, the calculation, it will pass that value. So now we have here the result is 100. Okay, the next step is console.log result. Now it will execute the console.log result and it says finished. So that was the last line that was executed. Now let's see the console. Okay, as we see here the console is 100. This was the execution phase and the creation phases. I would also like to talk about the call stack, which is about the execution phase, to see what happens in the execution phase. In the execution phase we have call stack. What the call stack will do, the call stack will manage all our function calls. Here in the example we have a function called add. It will take a and b and then it returns a plus b. We have a function called average. It will return, and in the return it will call the add function divided by 2. Finally we have a variable called x that calls the average function. Let's see how the call stack will work. Here in the call stack it calls the average function. The average function will call and the return will call the add function. Here as we see it returns add function, and once the add function is completed it will be removed from the call stack, and once the average is also completed, remove from the stack, and as we see here the call stack is empty. Okay, so here is the overall picture. We have the main, and in the main we have it called the average function called the add is completed, remove from the call stack. The average is also completed and removed, and now we have the empty call stack. What causes a stack overflow? A stack overflow occurs when there's a recursive function, a function that calls itself again and again without an exit point. Let's see the stack overflow in example. Here we have a function called say hello, and in the return it returns the same function as say hello. And here in the call stack we have say hello. The say hello will call itself again, say hello, and it repeats again and again. There's no exit point. And as we see here, the stack overflow happened. When the stack overflow happens, the JavaScript engine will throw us an error. It says that the maximum call stack size has exceeded. So the JavaScript engine will stop that function that it recursively call itself again and again. Let's see the call stack and in another example and see and visually how the call stack will work. Okay, so let's see visually how the call stack will work. Here we have the same function add, take a and b, we have function average. Now let's run this. Okay, so as we see here the average function is called. The average will call add function. Okay, now let's resume. So okay, now as we see here the a and a plus b is, and the calculation is in the call stack. Now let's resume. So once that is done, the a plus b that is removed from the call stack, the add is also removed. Now let's resume it again. The average is also removed. So here we have the call stack. It will put the average function. Let me run it again. So as we see here, the average 10 and 20, it calls the add, resume. So it will take the a and b, make the calculation, and then the call stack is empty now. Now that we understand about the global execution context, creation phase and execution phase, let's talk about the hoisting. Let me create a variable called counter, for example, equal to 10, and now console.log counter. Okay, so here in the console it says 10. What if we put the console.log before our variable? Now let's see again, it says undefined. Why this is undefined? This is because of the hoisting. So what the hoisting will do, it will take our variable and put it into the memory and initialize it as undefined during the creation phase. So it will look like something like this. Let me copy and put it here, and now initialize it as undefined. So in the execution phase, the JavaScript engine will read all our code line by line. So it will read counter as undefined. Now console.log counter, the counter is undefined. Here in the line 6 we have counter equal to 10. The value is 10. What it will do, it will put the counter as 10. But now it is too late because the execution in the execution phase, the console.log is already executed and it already displayed as undefined, even when we have the value for the counter as 10 now, but it is too late because the console.log is already executed. There's a difference between undefined and not defined, so let me make that clear. Okay, so let me comment this out, or let me delete this and comment that out. Okay, now it says that uncaught reference error counter is not defined. So the difference between undefined and not defined is that not defined means that the variable does not exist anywhere in the code, so it means it's not defined. But undefined mean is that we have our variable, which is counter, but it is not initialized, or there is no value for it. So in the hoisting example that we have here, let me run this code again. So in the hoisting, it says that the value is there in the code, but it is not initialized. We also have the function scope. So let me create a function to see the function scope. Hoisting, let's put the name as getShape, for example, and a variable called shape equal to square, and console.log shape. Okay, now let's call the function getShape. Let's see the console, it says a square, but what if we console.log the shape before it is declared? So now let's see again, it says undefined. So in the function scope we also have the same hoisting. Okay, so what it will happen, it will be something like this: var shape undefined. So now the function, when it starts executing, it will see the shape as undefined. It console.log the shape as undefined. Now the shape that has a square, but the console.log is already executed. So this is in the function scope. It works same as the global scope. But if we call our, so this is only in the function. Let me call that our console.log shape outside the functions. Okay, so console.log shape. So here it says that uncaught shape is not defined. So the shape is only defined inside the function, which cannot be accessed outside. So this is the function scope. Okay, now that we understand about the variable hoisting, let me talk about the function declaration hoisting. Let's say we have a function called getName, and I take name. It will console.log your name is name. Okay, now if we call our function getName and put, for example, John. Okay, it says your name is John. Now if we call our function before it is declared, so let's put it here on the top. Let's run the code again. It gives us the same result. So this is one of the benefits for the hoisting, which we can call our function declaration before it is declared. So here we called our function and then the function is declared. This was one of the benefits for the hoisting. Okay, so this was all about the hoisting in JavaScript. Hope you enjoyed this video. Thank you very much for watching.